Okay, so let's put it all together with some examples here. So construct a 90% confidence interval for the true mean of a normal population if a random sample size of 40 from a population yields a sample mean of 75 and the population has a standard deviation of 5. First thing you want to do is just start collecting some information. I want a 90% confidence interval. Okay, so 90%, right, confidence interval. That means my alpha must be 0.10. Okay, so again, this tells me it has a normal population. Okay, so remember, right? I need to know like the distribution. This is from chapter 7. Okay, so I have two ways of knowing whether I know that I have a normal distribution, or right, my sample size is larger than 30. Okay, if I have a large enough sample size. Right? So I need a normal distribution. So this gives me that. Okay, and then third, not third, but just let's just keep going. Sample size 40, n equals 40, 40 here. Population yield sample mean x bar equals 75. Okay, and standard deviation equals 5. Okay, so I know what the population standard deviation is. Okay, so let's go with our formula. So first I need my margin of error, right? My margin of error is critical value times the standard error of x bar. Okay, let's calculate the standard error first. Standard error of x bar equals to sigma over root n, which is 5 over square root of 40. Okay, and that will be 0.79. Okay, I'm gonna go a little quicker, but pause the video if you want to give this a try. Any parts here. Okay, and then second, I need my critical value. So my z critical value. Again, I'm using z because I know sigma. So I'm gonna look up my z critical value, and I'm gonna go ahead and just do a sketch here. Okay, gotta follow my own advice. I need to do a sketch. The sketch I'm looking for is, the critical value I'm looking for is going to be over here. My tail will be alpha half, which will be 0.05. Okay, so I'm gonna go ahead very quickly, go into my app here, go into normal distribution, 0, 1, here 0.05, and there we go. And my critical value is 1.645. Okay, all right. And then, so my margin of error is going to be 1.645 times 0.79, which equals 1.3. Okay, now my interval that I can construct now would be x bar, so 75 minus 1.3, comma 75 plus 1.3. Okay, which simplifies to 6.3. Okay, so this is right. This is a 90% confidence interval for mu. Okay? And in other words, we are 90% confident that this interval here contains the true population mu. That is our estimate. All right. Okay, now let's go ahead and do the second example. Go ahead and pause the video if you like to give this a try yourself. Okay, first thing again, collect your information. N equals 50. Okay, looking up the critical value. Okay, so I'll just skip that part. Okay, and by the way, after a while, right, given alpha, we use the same alpha, similar alphas most of the time, so the critical value is going to become very familiar. Okay, so again, calculate your standard error first. So 6 over root 50, which equals 0.849. And then my margin of error is going to equal 1.664. Okay, and then so my critical, my interval. Okay. Once I have my margin of error, interval is very easy to calculate. Okay, that is my 95% a 95% confidence interval. So, and we can make the statement, we can either say this is a 95% confidence interval for mu, right? Or again, we can also say, we should say we are 95% confident that this interval contains mu. Okay, so these are two. So you can feel free to express and describe a confidence interval in both of these ways. Both of these ways are fine. Okay. Okay, let's do an example with case 2 when sigma is unknown. Right. So I have a random sample, n equals 54. Sample mean of 22.5. Let's just copy that down. And sample standard deviation of 4.4. Okay, I don't know sigma. Now first, I still need to determine, so again from chapter 7, I still need to determine that it is indeed a normal distribution, meaning that my sample mean have a normal distribution, and it doesn't say that it's normal, but I do have my sample size is of 54, so it is large enough. Okay, so 90% confidence interval, that indicates my alpha equals 0.10. Okay, so just do a quick sketch. Just do a quick sketch here. My alpha is 0.10. That means alpha at half equals 0.05. And that's going to be my t critical value. Okay, so I need to look that up. And before I do that, I need my degree of freedom. So degree of freedom equals 54 minus 1 is going to be 53. Okay, so I looked it up, my critical value here. Okay, so what you want to do is go into t distribution. Okay, because I don't have sigma. My degree of freedom, it is 53. And then my area that I'm looking for is 0.05. And that is 1.674. So my t alpha at half equals 1.674. Okay, and then I'm going to go ahead and calculate so now all I need is my standard error first. So my standard error of x bar, again, I don't have sigma, so I'm going to use the sample standard deviation as an estimate for my sigma. Okay, square root of 54. Okay, calculate that. Okay, so 1.99, and so my margin of error is going to be 1.674 times 0.599. Okay, which gives me just 1.00, let's just call it 003. So my interval is going to be the same formula, x bar, so 22.5 minus 1.003, comma 22.5 plus 1.003. Okay, and that gives me okay, so my interval will be 21.497, comma 23.503. And so even though so the only difference here is that the critical value is different. Otherwise, the formula is the same, and the interpretation of the interval is the same as well. Okay, all right. I'll go ahead and give this one a try, or you can see, just see if you can figure out what changes. Go ahead and pause and check your answer here when you're done. Okay, so the only thing changing is that I'm now doing a 95% confidence interval, and my alpha is 0.05. So my t critical value, I need to look up where the area of 0.025 is. So my critical value is going to equal to, I'll just do that on the app here really quick. It's still 53, 0.025, 0.025, enter that, and that gives us 2.006. Okay, this is my critical value. Use that to calculate my margin of error. Times, I have my standard error calculated earlier already, which is 0.599. So my new margin of error is going to be okay 1.20. 1.20. Let's go ahead and round that to 1.202. Now, one thing you want to notice right away is that keep in mind my sample has not changed. This is my same data set, right? Imagine I go out, calculated the data, and my data set is exactly the same. I got a mean of 22.5 and a standard deviation of 4.4, right? But the only thing that changes here is my confidence level. My confidence interval went up. I want to be more confident, but what's the cost? In order for me to be more confident, right, using the same data set, my margin of error have to be bigger. Right? So notice that my margin of error has increased from 1.003 to 1.202. Okay, so I can't right. So I can't get something for nothing. So if I want to, make a more confident statement, right, I will need to increase my margin of error. Okay, and therefore I will have a wider interval as well. So go ahead and calculate that, and you will see that the width of my interval has increased. Okay, the center is the same; it's still at 22.5, right? But the width has definitely gotten bigger. Okay, 21.298 and 23.702. All right. So this is a 95% confidence interval. This is a 90% confidence interval. Okay. All right. Let's do one more example. One more example here. Okay. Given the following data drawn from a normal population and the unknown mean and variance. All right. A 95% confidence interval for the population mean. 7 value has been selected randomly from the population. Okay, so I have 7 values here, right? And my my n equals my n equals 7. Now how is my sample mean distributed? Well, I don't know. I can't use the central limit theorem because n is equals 7. It's too small. It's less than 30. But I assume that is the the sample is drawn from a normal population. Therefore, I can proceed with the problem because I know that sample mean will have a normal distribution. I want a 95% confidence interval, so that means my alpha equals 0.05. Okay, and so since I don't have the sample mean and I don't have the sample standard deviation, I will need to calculate this. First. So I'm going to go ahead and do this on the calculator, but you can do this on using any app or using Google Sheet if you like. Okay, so I did that on the side. All right, using this sample, and I got that x bar equals 29.86 and s equals 7.08. Okay, and since I don't know my standard deviation or the population standard deviation, then I need my degree of freedom because now I will need to use the t distribution. So my degree of freedom is going to be equal to 6. Okay, 95%. So my t critical value, let me find that out. Okay. Again, here my alpha half equals 0.025. And actually, so notice that I can't just use this earlier one, right? Because I have a different sample size. All right, so I need to use my app to find this. Again, I need to change my degree of freedom to 6, and the probability here is 0.025. Enter that. and that's going to be 2.447. Okay, so 2.447 there. Okay, all right, so I have everything I need. So now here we go. First, calculate margin of error. That's 2.447 times. Oh, I need my standard error. Excuse me, forgot to calculate that. Okay, my standard error there. Alright, I don't have sigma, so I'm going to use the sample standard deviation as an approximation. Okay, so root 7. Da, 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 2.676. Okay, there we go. 2.676. That's what I need. And okay, so I get 6.548. 6.548. So there we go. My interval is going to be 29.86 minus 6.548, and then 29.86 plus 6.548. Okay, let's do that on the side, and then I get 23.312. Okay, and 36.408. All right, so again, this is a 95% confidence interval for mu. Okay, that means we are 95% confident that the true mu, the true population average, is between or not between, but sorry, let me say it again. We are 95% confident that the true population average is in this interval. Okay, very good.